Ma présentation va être en anglais. Hi, my name is Ilya Brokin, and I'm a data scientist at Data Swati and research collaborator at the group of neural theory at ENS. And today I'm presenting you Data Science Challenge, Crack the Neural Code of the Brain, that I'm co-organizing with Ivan Lazarevich, who is a PhD student at Group of Neural Theory, and Boris Gutkin, who is a group leader there. And, Group of Neural Theory is one of the leading computational neuroscience groups at ENS, focusing on understanding information processing in the brain using tools from dynamical system theory, statistics, and machine learning. And by listening to this presentation, you will learn how to use data science to help to understand the brain. Look at these mice. Can you tell me what it is doing? Of course you can, if you can observe its behavior. But what if you cannot observe its behavior and I'm only showing you recording from a single neuron in its brain? Can you tell me the state of the brain just by looking at the sequence of activation times of neurons? Well, it's a difficult problem, and it's what this challenge is about. We have data from the mice in two different states. Like, let's say mice can be playing with another mice, or I don't know, watching YouTube videos. We are not telling you what it is. Two states, and you have data from single neurons. Can you discriminate between these two states? So it's a binary classification problem, right? And the type of data is time series of neuron activation times. So, on the upper part of the slide, you see the scheme of the workflow that you are going to have. So you have data from different neurons. For each neuron, let's say neuron I, the one in black, you have sequence of activation times. Then in your model, you're going to use this to predict the state label, if it's state 1 or state 2. So your target variable is just a label, state 1 or state 2, and data is organized into classical tabular form. So for first column will be ID of time series, then ID of a neuron, and then following columns are 50 consequent timestamps of neuron activation. You will have 16,000 lines for your train set and around 12,000 lines for your test set. We'll evaluate your model using Cohen-Kappa score, which is a good score for class imbalance problems. And to help you get started, here are some ideas that we used in our benchmark model. Take time series of neuron activation times, compute the first difference. So you go from sequence of times to sequence of intervals between activations. Then featureize this time series, compute various features like mean, standard deviation, median, trend, etc. Then use some baseline classification model, such as random forest on this featureized time series. And this simple approach gives you Kappa score around 0.3. And we challenge you to beat this score, and I really hope you'll come up with a great model that will beat our score because it will help us to develop high accuracy neural decoding systems and also classify predictive information in different regions of the brain. And to make it more interesting for you, we'll post information about possible prizes on our Slack channel that I invite you to join. Thanks for your attention, and please go to this link and join our Slack channel and discuss with us and other participants. I'm really looking forward to chat with you. Thanks.